Hi, and welcome to the Unit 6, Day 7, two-step mole conversion problems. So, as you saw from the intro video, the two-step mole conversion problems are very similar to the one-step mole conversion problems. In that the first thing that you're going to do in these problems is you're going to choose the right conversion factor. To do that, you read the problem, identify your given and your find, map out your plan to go from your given to your find, and then you choose the right conversion factor, and you can use either the mole map or your understanding of the units to do that. Now, with that being said, the main difference between these two-step problems and these one-step problems, and when I say step, I'm not referring to this right here, the actual process. In a one-step problem, you only choose one conversion factor, and in a two-step problem, you're going to choose two. After you've picked the right conversion factors that you need, then the next step in this process is to solve using dimensional analysis, okay? So I think the best thing to do is just dive right into our example problems. All right, so the first thing we're going to do is we're going to read this problem and identify our given and find. Convert 4.36 times 10 to the 25 molecules of CH3OH to grams. So you can sort of think of this problem as if you have a sack of, this is methanol, like a bag containing 4.36 times 10 to the 25, so a really big number of methanol molecules, and you would want to know how much that would weigh. That's what you're trying to do here. So in this case, our given is the number of molecules. And what we're trying to find when we see grams, remember that's a key word, that means we're looking for mass. So we're trying to go from let's use our mole map here, we're trying to go from the number of molecules to the mass. Now we can't do that directly, there's no line connecting them directly, but we'll go from the number of particles to the moles, and then from the moles to the mass. So our plan here is to go from number of molecules to the moles, and then from the moles to the mass. Now to do this, there will be two conversion factors that we pass through. The first conversion factor we're going to pass through is 1 mole is equal to 6.02 times 10 to the 23 things, or 1 mole is equal to Avogadro's number. So our first conversion factor is 1 mole is equal to 6.02 times 10 to the 23, and we're dealing with molecules. Remember, for Avogadro's number, the units will depend on whatever it is that you're counting. In this case, it's molecules. Now, once we've gotten to moles from the number of particles or molecules, we're going to go from moles now to mass, and to do that, we pass through the conversion factor that 1 mole is equal to the molar mass, and this will be the molar mass of methanol, CH3OH. So before we go any further, we're going to calculate the molar mass of methanol using our periodic table. Methanol has 1 carbon, 4 hydrogens, and 1 oxygen. So we're going to add up all of their average atomic masses. Okay? So my work for that would look something like this. I have 12.01, that's the molar mass of, or the average atomic mass of carbon, plus 4 times 1.01, which is the average atomic mass of hydrogen, plus 16, which is the average atomic mass of oxygen. And then I would add all those together, and I get that the molar mass is equal to 64.52 grams, okay? All right, so that's that part done. I got my plan, I got my conversion factors. Now I need to do my dimensional analysis. So for these problems with dimensional analysis, it's the same as before. You start with given over 1. So our given is 4.36. I'm putting it over 1. And remember, we do that just to make it into a fraction, so it makes our math easier. So there should be no units here. It's just over 1 to make it into a fraction. Now, the difference between a one-step and a two-step, in a one-step problem, you would only have one conversion factor, but in two steps, remember, we have to pass through 2. So we actually need both of them. So in the first conversion factor, we're going from number of molecules to moles. I want to find moles, so the 1 mole is going to go on top, and then Avogadro's number goes on the bottom, so I can cancel out the units of number of molecules. Okay, now the second conversion factor that I'm going to use is going to go from moles to mass. Now, because these number of molecules already cancel out, right? So now for this second conversion factor, I have moles that I want to get rid of, so that's going to go on the bottom, so they'll be opposite. It'll be 1 mole. And is equal to the 64.52 grams, so the 64.52 grams goes on top. So let's just pause for a quick second. So I started by taking my given, I wrote it over 1. That's this first part here. So my given over 1. Then the second part, the second fraction comes from my first conversion factor, 1 mole is equal to 6.02 times 10 to 23 molecules. I took this equation, turned it into a fraction. I put the 1 mole on top and then the 6.02 times 10 to 23 molecules on the bottom, so the number of molecules will cancel out. So notice how the second fraction, 1 mole, will go on top, and then the conversion factor, the given, goes on the bottom. Then in the third fraction here, that comes from the second conversion factor. So 1 mole is equal to 64.52 grams, so 1 mole of methanol is equal to its molar mass. And in this conversion factor, I put the 1 mole on the bottom and then the mass on top so that the moles now can cancel out, leaving me with the units I want in the end, which is grams for my mass. Okay, so now we're ready to do the math. What exactly does the math look like? Remember, when you're multiplying fractions, you multiply straight across. So this would be 4.36 times 10 to the 25 times 1 times 64.52 in the numerator. So 4.36 times 10 to the 25 times 1 times 64.52, right? And then the denominator, I would have 1 times 6.02 times 10 to the 23 times 1, which is just going to be 6.02 times 10 to the 23. Okay, so I go ahead and I multiply my numerators together, so just so you can see what that looks like in the calculator. Remember, when you're using these exponents, you want to be careful and put parentheses around things. So I open my parentheses, I do 4.36. Second, I like to use the e function as my times 10 to the 25. Okay, so that's how I do that part. Notice there's no 10 there, there's no multiplication, I just do the big E and then the 25, which is the power of 10. All right, so we're going to take that, we're going to go ahead and close that parentheses. Now times that by 64.52. And I get this big number, that's what's on top there. And then I'm going to divide that now by the 6.02 times 10 to the 23. And once again, just to be safe, I like to put everything in parentheses. If you use parentheses, more parentheses than you need, it may not be the most effective, but it'll at least guarantee that you're getting your answer correct. Okay, and now we get this huge number here. So this is 4,673 about, but because we have only 3 sig figs in this problem, it'll be 4,670 grams. So that will be my final answer. All right, so just to quickly recap, you do the same thing that you did before. Read the problem, find your given and your find. Then use your mole map to sort of map it out. Notice that there'll be 2 arrows here. You'll write down 3 things and separate it by 2 arrows in your plan. Then you identify the conversion factors you need to complete that plan. And then to set up your dimensional analysis, it's given over 1. Then it's going to be 1 mole over the conversion factor of your given. And then you're going to get that from the conversion factor you use, over the conversion factor of your find over 1 mole. So the 1 moles will cancel out. Okay, let's go ahead and just do another problem now. So in this problem, it asks how many liters of neon gas would you have in a 2.3 gram sample of neon at STP. So I am given my mass, I want to find my volume in liters. All right, so my plan, I'm starting here at the mass. I want to go over here to volume at STP. So from mass, I go to moles. From moles, I go to volume. Now, what conversion factors do I need to do that? So starting with mass to moles. From mass to moles, I'm going to use 1 mole is equal to the molar mass. And for neon, that is the average atomic mass on the periodic table, so 20.18 grams. All right, now we're here at moles. We want to go from moles to volume at STP. We use the conversion factor 1 mole is equal to 22.4 liters. Okay. All right, now we're going to start with our given over 1, 2.3 grams. I put it over 1, doing that just to make it into a fraction. Now, I need to convert this to moles, so I'm going to use my first conversion factor here. I want to get rid of the grams, so the 20.18 grams in that conversion factor goes on the bottom. And then the 1 mole goes on top. So I just took this equation and made it into that fraction. Now my second conversion factor fraction is going to come from my second conversion factor. So in this case, I want to cancel out the moles. So the 1 mole goes on the bottom. And I want to put the 22.4 liters on top, since that's what I'm trying to find. All right, the math for this will look like the following. You multiply straight across, so 2.3 times 1 times 22.4. So that's just going to be 2.3 times 22.4. And on the bottom, it's going to be 1 times 20.18 times 1, which is just 20.18. And when you do that math in your calculator, 2.3 times 22.4 divided by 20.18, you get the following value. And I only have 2 sig figs here, so I'm going to round this off to 2.6 liters. So that means that the amount of neon gas that I have that would weigh 2.3 grams would be 2.6 liters. Okay, last problem. How a 418 milliliter tank of oxygen contains how many O2 molecules, right? So we are trying to go from a volume, it's in milliliters, but we're going from volume to number of molecules. So from here, I want to get to here. So to do that, I go from volume to moles. So volume to moles, and then from moles to number of particles. Notice you always have to pass through moles. That's the central unit of conversion. Okay, now my conversion factors. To go from volume to mole, I pass through 1 mole is equal to 22.4 liters. And then to go from moles to number of particles, I pass through 1 mole is equal to Avogadro's number. Okay, now before I get started, remember that sometimes when we're doing this, if we need to, we have to convert units of our given first. So I'm going to need to do that here. So I'm given my units in 418 milliliters. Remember, this can't be in milliliters, it needs to be in liters. So to convert it to go from milliliters to liters, I have to divide by 1,000. All right, so I'm going to divide 418 divided by 1,000. And that gives me 0.4118 liters. So that's what I'm starting with here. So 0.418 liters over 1, that's my given over 1. Now my next conversion factor is going to come from, my first conversion factor is going to come from this. 1 mole is equal to 22.4 liters. I'm going to put the 1 mole on top and the 22.4 liters on the bottom, so that the liters will cancel out. And then I have the next conversion factor will come from 1 mole is equal to Avogadro's number. So the 1 mole goes on the bottom, so the moles cancel out. And the units here are molecules. Okay, and then I can go ahead and do my math. So 0.418 times 6.02 second E 23 divided by 22.4, and that gives me this number here, 1.1 2 times 10 to the 22 molecules. All right, so what you're going to do now that you've seen these 3 problems done, or you're going to do that for the 2-step mole practice problems. It starts on this page, and then there's a few more problems on the next page. You're going to do that and then check and correct your answer. After you've done that, then there's some mixed practice problems. And for the mixed practice problems, some of them will be like what we've done today, the 2-step mole conversion, and some will be the 1-step mole conversion. So you have to decide. Now remember that if you have a 1-step mole conversion, at least one of your givens, either your given or your find, is going to be in moles. And if it's 2 steps, your given and your find will not be in moles. All right, so that is it for this video. Hope you found it helpful. Have a quality day.